Well, after covering the definition, let's look at the process of remote sensing. Since we have to get information about some object, that object will need to be illuminated, or you should be able to see the object. Let's try and understand in very simple terms how even now what's happening. The camera is recording me. That's in a way remote sensing, or rather that is exactly remote sensing. But the camera can detect me or is filming me only because there is sufficient enough illumination by these two spotlights which are here in the studio. Imagine a situation where suddenly the power fails, there is no light. Well, the camera is on, but it will not be able to detect me. You can see me now. So the primary need for any remote sensing is a source of illumination. Conventionally, illumination would be only in the visible spectra. That means light the way we humans understand it, or the way our eyes perceive light. But remote sensing is also done in other wavelengths, like in the infrared, also in the radar region, in the thermal infrared. So let's understand the process. The first step is you need illumination. In our case, the primary illumination all around comes from the sun. So you have sun's energy transmitting through space, coming through the atmospheric layers of the earth, falling on the earth's surface. As it transmits to the earth, there are some wavelengths which get absorbed, some just don't come through. The light falls on the earth's surface, interacts with it. Now the term interact means a lot. Every object on the earth's surface has its own intrinsic properties of absorbing and reflecting sunlight. So as the light falls, it interacts. Whatever is reflected from the object, and some of it also radiated from the object, transmits again back through the Earth's atmosphere and would be detected by a sensor. The sensor can be on board the satellites which we have launched. It can be on a sensor which is on an aircraft, and today very popularly it could also be on drones. So that's the first step, that's detection. You have recorded the signal. The next step is whatever data you have collected is either downloaded or transmitted to a earth station or a processing center, where in very rather mathematical ways corrections need to be done. So these primary corrections are done by the organizations which own these satellites, which could be government or which could be the private sector. It's only after these preliminary corrections that the digital data, or even in print form, is made available to users like you and me. And it is users like you and me who, using the domain knowledge which we have, that we interpret the imagery. So, well, I'm a geologist, I'll interpret it primarily for understanding the rocks, understanding the rock structure. You could be an agricultural scientist. You can use the same data for finding out areas in a farmland which are right now having standing crop. You can use it for finding areas which are about to be infected by a specific fungus or a specific disease. The same data again, exactly the same imagery, could be used by a town planner if tomorrow the same area is going to have urban development. So the applications are tremendous. It's only left to the imagination and ideas which you have. Thank you.